Hello, and, and welcome to this session of the 2020 GEO Virtual Symposium, Earth Observations for COVID-19 Response and Recovery. I am John Haynes of NASA headquarters, and I'm serving as your facilitator today, along with Julie Turtan of NOAA, Astrid Christina Koch of the European Commission, and Helena Chapman of NASA headquarters. Julie and I also serve as co-chairs of the GEO Health Community of Practice. And many thanks to the GEO Secretariat for giving us this opportunity to speak with you today. Earth observations offer real-time information that can advance scientific inquiry, inform health decision-making, and enhance interventions to address emerging global health challenges. In light of the COVID-19 pandemic, the GEO Health Community of Practice has taken action to leverage global expertise, share resources, and discuss priorities and challenges across geographic regions, primarily through a series of weekly telecons. This session will highlight the value of this global network, present scientific approaches and preliminary findings, and provide recommendations that support Earth observations for public health applications. The presentations you will hear today directly grew from the weekly meetings of the Community of Practice, including deep dive discussions on environmental factors related to the pandemic. At the end of the session, we will provide community resources and data portals, as well as information on how to join the GEO Health Community of Practice and other upcoming workshops and meetings. I encourage you to get involved. In fact, in a demonstration on international collaboration, next week ESA, NASA, and JAXA plan to launch a trilateral COVID-19 dashboard that will serve as a one-stop shop for many different types of environmental and economic indicators related to the pandemic. With that said, I will now ask if any of my co-facilitators have anything to add before we jump into our session.
Good morning, everyone, and thank you very much, John. This is Julie Turtan from NOAA, as John mentioned, co-chair. I just want to welcome everybody and thank you for getting up early, staying up late, or joining us from wherever you are. We're looking forward to our session and to the rest of the week. Thank you very much.
Astrid, Helena, do you have anything to add?
Hello, hi, here's Astrid. Maybe we just do a little exercise. We will do this together. We hold hands and then go up and stretch a little bit to the left and stretch a little bit to the right. And whenever you get, yes, and hello, everyone, and great session. So please start. Great team worldwide. Thanks for joining us.
Thank you, Astrid. We needed that. Yes, Helena.
And this is Helena Chapman. Thank you so much, Astrid, for having this lively presentation and echoing John, Julie, and Astrid. We look forward to this session today, to learning from each other and sharing resources.
Thank you, Helena. So let's get on with the session. To begin our session this morning, or afternoon or evening, depending on where you are, I would like to introduce Dr. Ben Zaitchik of Johns Hopkins University in the USA. Johns Hopkins has become a world leader in the dissemination of COVID-19 data through their Coronavirus Research Center, which Dr. Zaitchik is part of. Dr. Zaitchik will present today on hydrometeorological sensitivities of COVID-19, challenges and opportunities for Earth observation. Let's begin his presentation.
Hello, everyone. Thank you for the opportunity to present to you today in this important session on links between the GEO community and the current COVID-19 crisis. My name is Ben Zaitchik. I'm an associate professor at Johns Hopkins University. I'm going to be speaking to you briefly about some of the challenges and opportunities on linking GEO observations of hydrometeorology to the current COVID pandemic. So, to begin with, I don't think anyone needs to be reminded of where we stand right now. This is live as of
Well, while we work to get Ben's video reloaded again, I have been asked to remind participants of if you would like to ask questions, and we will have a question and answer session at the end of this session, toward the end of this session, a question and answer period, that your Slido code is GEO. So if you would like to pose a question to any of our presenters or the facilitators, that is the code you'll use on Slido, GEO. And we'll have an opportunity to answer those questions toward the end of our time block.
This is live as of when I recorded this presentation, about a week before it will be provided to you. Looking at the global case number on the Johns Hopkins University dashboard, and we see that we are going through this extreme pandemic that is beginning to show signs of slowing in some places, at least for now, but is increasing in others. Now, looking at a map like this and seeing that it is everywhere in the world, one might ask, why do we even entertain the idea of hydrometeorological sensitivities when clearly this disease can survive from Sweden to India and from South Africa to Ghana? And so there are a few reasons why we might expect some kind of climatic sensitivity, as most of you have probably heard discussed in the popular media, if not the research community. And that is simply because COVID-19 is a respiratory pathogen, and these kinds of respiratory pathogens are known very often, not always, but very often, to exhibit seasonality in temperate regions, which we believe is due to environmental factors, largely meteorologically driven. And here we see from a recent review article, not on COVID-19 specifically, but on these such pathogens, there are several reasons this might happen, having to do with both the outdoor environment, the indoor environment, direct impacts of hydrometeorology on the virus itself, as well as impacts of those hydrometeorological factors on the host. There is a good reason to believe that this matters from a process perspective. And we think we know something about what variables matter. Not so much for COVID-19, I'll come back to that. There's a lot of uncertainty, some claims out there, but certainly dominated by uncertainty right now. We know that for influenza, which we know best, as well as some other viruses, that there's a sensitivity that's been observed either empirically or through lab-based and other studies, that these viruses could be sensitive to temperature, to absolute and relative humidity, and to UV radiation, impacting, again, both the virus itself and the factors that lead to transmission. So these are kind of some leading candidates. And so coming to us as the GEO community of practice, we really see that there are some great opportunities for us to understanding here. And why? Because we do this stuff well as a GEO community. So just to give some examples, can we do UV at the surface? Yes, we can, through data sets such as the Tropomi Surface UV Index. Can we do temperature? Yes. So here's just an example of the CHERTS Surface Temperature Project, a cloud-free composite produced by the Climate Hazard Center. And that's at 0.05 degrees resolution. Can we do specific humidity? Well, that's a little trickier for us. You know, our direct satellite observations aren't necessarily getting us to near surface specific humidity, but we can, through our data assimilation and reanalysis products, for example, here's the North American Land Data Assimilation System product for daily surface specific humidity, we can create satellite informed products that then can be used to draw time series. Here, for example, some work we're doing, time series for a county in the United States during the unfolding of the pandemic. So yes, we can get these variables. So it seems here that we've got a great opportunity. Where do we stand on actually providing some answers on the hydrometeorological sensitivities of COVID? And this is where the news gets a little less promising. Here, a student in my group has compiled, not complete by any sense, but representative of some studies that have looked at temperature sensitivities of COVID-19 transmission. And what you're seeing here are the bar charts are organized to show you the duration of the training data used to develop usually an empirically informed model, either of the transmission rate or of case count or some other relevant outcome. And if it's blue here, it means they found that as temperature increases, the susceptibility to the virus decreased, or the rate of transmission decreased. If it's red, the opposite is true. If it's gray, it was neutral and non-significant. So you see here, despite the fact that we've got some biophysical reasons to expect this kind of sensitivity, there's not a consensus yet. The answers are all over the map, and it depends on exactly which data went in, what they're trying to predict, as well as what the time period of data collection was. You can then look at humidity. It's even more uncertain. So first of all, some are looking at relative humidity, some specific humidity, looking at different data, different time periods, and really nothing that we can say with any certainty. Some ranges perhaps have been identified for optimal transmission, but not a statistically significant result that seems robust everywhere. One might say, well, that's because the globe is too complicated. Let's look at some place more specific. So here's just one example for China. And yes, now maybe the majority of the studies are showing a negative relationship with temperature, so maybe we're getting somewhere. But again, that's still far from comprehensive or a consensus result. Looking at humidity in China, a total mix. Okay, so here's a place where we have the earliest case records, and yet still uncertain what humidity is doing. And so what's going on? Well, I think it's fairly obvious to us. One issue is we're dealing with an evolving pandemic. And so as an evolving pandemic, we can't expect to have stable case counts to work with. The dynamics are shifting as we study them. A second point that we have to take quite seriously is that there are other factors that are going on that are correlated in time. This is an epidemic that started in the mid-latitude northern hemisphere winter, and as we move into spring, showing here some analysis from Italy, similar results our group is going to be publishing soon for the United States, we see that as social distancing on the left side of your screen became more effective, so people became more socially distanced relative to baseline, we can then see a flattening of the case count curve. That's happening as it's getting warmer at the same time, as it's getting higher specific humidity levels. We need to be able to disentangle that, and that's very complicated to do. And then, perhaps most importantly, going back to this picture of the dashboard case count, our data on the cases are inconsistent and unreliable in many places. So we have different spatial resolution, different temporal coverage, changing case measurement frequency. Determining what the proper response variable is difficult. Is it the total case count? Is it the doubling rate? Is it excess deaths? All of this is moving as we move forward. So in some sense, the Earth observations very often are ready, but some of the complementary data are not quite ready. And so given this context, all right, where we've got a reasonable understanding of why we would expect to see sensitivity, albeit through pathways that are not to be determined, and where we have Earth observations, that as a group on Earth observations, we are ready to provide and developing all the time, what can we do to contribute usefully as the pandemic unfolds? And I argue there are a few things that we can do even in the context of this uncertainty. The first, as many are already working to do, certainly the National Oceanographic and Atmospheric Administration in the United States, as well as Copernicus in Europe, have been very good at trying to make data accessible, usable. This means really finding out what formats are needed, at what scale and space and time are needed by our epidemiological colleagues, and also understood. Do we really know what's happening in these data? We need to make sure that others are able to interpret what we put out there. Second point is collaboration is key here. In this evolving literature, we see a number of examples where Earth observation specialists are working not in isolation, but perhaps without full engagement of disease experts. And so then you end up with some results that might be robust from the Earth observation perspective, but can be, honestly, sometimes misleading when we don't take proper account of the expertise on disease transmission. So that needs to be incorporated. And finally, I think, communication with our community has been critical. GEO has been wonderful for this, to make sure that we are in touch with each other and also in good position to reach out beyond our community. We all need help doing that. And that we want to think creatively about Earth observations. I've only had time to talk about a few key variables, but there could be many more. And we want to think about how Earth observations could inform our understanding and the predictability of the pandemic. So with that, I will thank you for your attention and end.
All right. Thank you, Ben. And we will remember to ask your questions through Slido if you have them. So we will open it up at the end for questions. So please go ahead and do that. And at this point, I'm pleased to introduce our next speaker, Professor Francois Engelbrecht. He joins us from the University of Witwatersrand. I'm not saying that correctly. Comes to us also from the climate modeling side of things. And as Ben mentioned, there are lots of questions still surrounding around the environmental drivers of COVID. And one of the big questions is, what is the seasonality and what are those trends? Professor Engelbrecht is going to address some of that with us. And I believe that we will go straight to the video now. Thank you, Francois.
Good day to everybody from South Africa, where a cold front has just moved deep into the interior and winter has arrived. This talk is indeed about exploring how seasonality may impact on COVID-19 infection rates here in South Africa, but also, of course, across the world. I am Professor of Climatology at the Global Change Institute at the University of the Witwatersrand, that is in Johannesburg, South Africa. My field of speciality is the projection of future climate change over Africa and therefore also climate modeling. But like many other climatologists across the world, over the last few months, I've shifted my focus to investigate the potential impacts of seasonality and temperature and humidity anomalies in particular on COVID-19 infection rates. In South Africa, we formed a consortium of environmental scientists that are focused on investigating this topic. We call ourselves the COVID-19 Environmental Reference Group. We are functioning under the auspices of the Department of Science and Innovation in South Africa. And our efforts are linked to the national epidemiological modeling effort in the country. The main question for us is, of course, how the South African winter may enhance COVID-19 infection rates in the country. And that is the critical question right now in the Southern Hemisphere. And then, of course, the other important focus that I think climatologists can bring to the COVID-19 epidemiological effort is our experience in working with scenarios. So climate change scientists, as I'm sure you all know, have a lot of experience in working with large multimodal ensembles of projections of the future, often under very different scenarios. In our case, it's usually low and high mitigation greenhouse gas scenarios that then impact on climate. And in South Africa, we are also then trying to share this experience with the epidemiological modelers. The main algorithm I'll be using today when sharing some thoughts on seasonality had its origins in the early days of the COVID-19 outbreak. It's mostly based on empirical studies performed initially in China, but later also, of course, in Europe and the United States. I'm not advocating at all that this algorithm is the true one in terms of representing seasonality. I am merely using it as an example of how COVID-19 seasonality may manifest in reality. In this algorithm I'm using today, COVID-19 infection rates are peaking climatologically wise between 5 and 11 degrees Celsius. That's when the daily average temperature is within those bounds. And then there's a secondary effect of the infection rate being reduced when the absolute humidity rises to above values of 9 grams per cubic meter. When we apply this algorithm to South African climate, we get the maps that you can see on the screen. By the time that we reached mid-winter conditions in South Africa, June in the map, bottom right part of the map, absolute humidity is so low and temperatures are so low that COVID-19 infection rates are peaking, according to this algorithm in South Africa. So we refer to this modifying effect of climate on infection rates as the climate correction factor. It's scaled as a factor ranging between 0 and 1. In March, when we had the onset of the disease in South Africa, you can see that the factor reaches values of about 0.7 over the South African interior. And And that is just because in March there's still a great deal of moisture in circulation and temperatures are substantially higher than in June. And it effectively means that when the disease started in South Africa in March, the impact of climate on the infection rate had the effect of reducing the infection rate by about 30 to 40% compared to the June infection rate. That is now, of course, under the assumption, the very strong assumption of this specific algorithm. And then the situation continues. If it is true that low humidity and low temperatures are boosting the COVID-19 infection rate, then of course it's bad news for South Africa. Our interior is extremely dry in winter, and it's very cold in winter. It's a typical continental climate with warm, cold seasonality. And that means that for the next 3 months, we'll be living in peak infection conditions as far as seasonality is concerned, at least in the interior of South Africa. It also, to a large extent, to the coastal areas, this enhanced effect of seasonality on infection rate. And it's only when spring arrives with the higher temperatures and the first fluxes of moisture again into the country that we can expect some relief from this effect. This slide just zooms into the seasonal cycle of average daily temperature, top graphic, and the climate correction factor, bottom graphic for Johannesburg. Now, South Africa's industrial heartland is centered around Johannesburg. About 15 million people live in this part of the country. We refer to it, it's known as the Gauteng province. And it's a typical continental climate that Johannesburg has. You can see that average temperatures drop to about 10 degrees Celsius in the middle of winter. Absolute humidity is very, very high. It's very, very low, and that translates to this high climate correction factor. That means, in terms of how the algorithm is formulated, peak conditions in terms of climate effects on infection rate. In the last part of this talk, I'd like to show how we've been applying this algorithm within a third epidemiological model to investigate how seasonality may influence the sensitivity of the infection rate. In this model, the infection rate is assumed to have a value of about 0.319. The recovery rate is about 0.16. The rate at which people are dying is about 0.005. All of these values are expressed per day, of course, and it translates to an R0 value of about 2. In the simulations I'm going to show, the population size is 12 million people. The disease starts on the 5th of March with a single infected person. And then 2 non-pharmaceutical control measures are assumed in this model. First, a very strict national lockdown, replicating what South Africa indeed had in terms of a lockdown, that reduces the infection rate by a factor of about 0.63. And then in early May, that changes to about 0.8. That's the time that South Africa started to relax its national lockdown. The purpose of this model is purely to perform theoretical simulations exploring the impacts of seasonality on COVID-19 infection rate. These are the types of output the model produces. If we start with a value of R0 equal to 2.4 and we exclude all seasonality effects, we get the black curve in that graphic. It predicts that in the Gauteng province of South Africa, the infection will peak around about in early July. And you will see that more than 1.6 million people will be infected at the time of the peak infection. This is very much consistent with the current national predictions that are being issued for South Africa. Now, the green curve represents the impacts of seasonality. You can see that there's almost no impact in terms of the amplitude of the peak infection. But the peak infection is delayed by about 1 month. That is purely because under these assumptions of seasonality as we've made them in the work I'm presenting today, the high temperatures in autumn are greatly damping the infection rate. and it's only in winter that the infection really gets going within the South African population. Now, if we consider lower infection rates, for example, for a start R0 equal to 2.2, you can see the same effect. Seasonality delays the time by which we reach the peak infection. But now you can also see a secondary effect, namely that the amplitude of the peak infection is being reduced. In this case, the disease is not managing to reach its full potential during those 3 months of midwinter conditions. And when spring arrives, there's once again a dampening of the infection rate, and that results in a reduced peak infection. This effect is even more clearly visible at even lower infection rates, like in this example I've just added, R0 equal to 2. And then something very interesting happens at even lower inherent infection rates. For R0 equal to 1.5, that thick green line shows the case without any seasonality effects. So you can see that now already the amplitude of the peak infection is substantially reduced, purely because the infection rate itself is lower, and the disease only peaks in early October. But in this case, the dampening effect of seasonality is so strong that the disease just gets going in winter. There's a bit of momentum into spring, and then it gets damped out again by summer. Now in this case, if we zoom into that blue line, not only looking at 2020 but also at 2021, we can see a very interesting and potentially a very important effect. Namely that if seasonality is very strong and on the low infection rates, we can see that the disease has a relatively small peak infection in 2020. It then gets damped out almost completely by the summer of 2020-21. But there's a great enough portion of susceptible people left in the population for the disease to reach a much larger amplitude in peak infection during the winter of 2021. So remember, in this case, the disease keeps on lingering in the population. And for the winter of 2021, there's in fact a larger number of infected people that provides a more favorable initial condition for the disease to develop from in the winter of 2021 compared to the winter of 2020. So to conclude, the main message I'd like to share today is that it is important for epidemiological models to include seasonality in the form of a scenario. So it's important to consider right now in the Southern Hemisphere how winter may be enhancing infection rates. And of course, for the Northern Hemisphere, it's important to take into account that summer is damping those infection rates. But what will happen in the following year if there's still a large number of people in the population that are susceptible? In South Africa, we've submitted a review paper on this topic of seasonality, and I think like everybody else, we've come to the insight that right now there's no consensus and there's no clarity on how important seasonality is. But that's why it is so important to include it as a scenario in predictions, as I've mentioned. There are ongoing inverse modeling efforts within our consortium in terms of exploring seasonality impacts on infection rates. Of course, most of our work is through the lens of South Africa and South African infections. The national modeling effort in South Africa that is informing government policy is including seasonality. So this algorithm I've been presenting and its resulting impacts on the infection rate is being used in our national model that runs across 4,300 different wards in South Africa. And then finally, you can see a link there in the very last bullet. We've also written an opinion piece on how the knowledge of climate change scientists in terms of dealing with scenarios and multi-model ensembles may help epidemiological modelers in their interactions with governments across the world right now. The very last thing I'd like to say is that our consortium CIRC is also involved in an initiative of a big international conference coming up in early August. It will be focused on the meteorological and environmental drivers in the COVID-19 pandemic, All the details are on this last slide. I won't mention all of them, except that the World Meteorological Organization is going to be the main host, and the main sponsor is no organization else but GEO Health. The AGU will be the technological host, and there will be various international partners involved. A contact person of Neville Swade of South Africa, who is involved in the organizing committee, is provided there. And I think this is a next international meeting to look forward to, where we can share our knowledge or our insights into seasonality and COVID-19 infection rates. Thank you to Elena and the colleagues from GEO for this opportunity to share some insights from South Africa.
Super. Thank you very much. Greatly appreciate, Francois, and I think we will also advertise your upcoming conference at the GEO Health Community of Practice. Let's move on in our world tour. Let's move on to our world tour to Japan, and we would like to invite Osamu Ochiai, who is a senior engineer at the Satellite Applications and Operations Center of JAXA. He is known by a lot of people because he's been to the GEO Secretariat as a senior official working on data as a data expert, and he is the lead person for CEOS for the GFOI, which is an important flagship of GEO. So now let's move on to Japan with Osamu. Great to see you. Okay, can we start the presentation? That'd be wonderful. Thank you.
So I am going to introduce briefly about JAXA Earth observation activities on COVID-19. First of all, I would like to express my sincere condolences to all the victims of COVID-19. Let me introduce by myself. My name is Osamu Ochiai, Associate Senior Engineer of JAXA, and I'm also serving a technical advisor next Japan. Some of you may know me. I have experienced more than 25 years to develop Earth observation system and information system. And I also spent 7 years in GeoSecretary so that I know what GEO. And I'm also a sales lead on Global Earth Forest Observation Initiative. We call the GFOI as one of GEO flagship. Today, I'm going to provide what activity has happened in JAXA in terms of contribution to the COVID-19. As you may know, JAXA is a public space agency in Japan, and currently there are 6 Earth observation satellites operating in space. The objectives of these satellite missions are mainly for monitoring Earth's environment and climate, as well as disasters at global, regional, and local scales. Since the last months, during the unprecedented situation of COVID-19, we had started to discuss what we can contribute to society by using our Earth observation satellites. Although most of the JAXA staffs have been working at home, we had very intensive discussion via online meetings. We understand that we cannot observe COVID-19 itself, of course, but we think that we may be able to observe from space any impacts of COVID-19 in the world. Using JAXA's Earth observation satellite, we may be able to monitor the change of CO2 and aerosols in atmosphere and social infrastructure and supply chain, ocean parameters, and so on. Subsequently, we identified our potential contribution. We have started to monitor these parameters. From the next slide, I will introduce 2 parameters that we are currently monitoring, particularly focusing on CO2 and aerosol. This is one of the examples of aerosol monitoring in Los Angeles as a major air quality parameter. We have used GECOM City Satellite as global climate observing mission for climate, in short, which onboard SGLI instrument as a second-generation global imager. The instrument can detect 19 wavelength bands of radiation from near ultraviolet to thermal infrared region, which yield various physical properties related to cloud, water, snow, ice, aerosol, sea, land, vegetation, so on and so forth. The spatial resolution is 250 meters, and observation source-wise is greater than 1,000 kilometers. The whole globe can be scanned approximately in every 2 days. You can see in comparison between average aerosol optical thickness we call the AOT in May 1 to 10th from 2018, 2019, and 2020, as you can see. The AOT in 2020 May, which has during the lockdown, can be seen less than other two past 2 years. In seeing the result, we would like to jump in the conclusion that this is because of the lockdown, but you see the standard deviation is somewhat large. It would be hard to say from our side that the AOT would be really decreasing. The graph shows the monthly trend plot of AOT in 3 years. 2018 is black, 19 is blue, and 20 is red. This also shows that before lockdown, the trend of 3 years are not shown of significant change. After LA lockdown on March 19th, the result of the April and May are dropped from last 2 years. However, again, we cannot firmly say that this is the result of the lockdown, nor identify the origin of the effect. From satellite community ourselves, ground truth data is very important to validate. In order to validate these results from the satellite observation, we can firstly compare to ground-based meteorological data such as temperature, humidity, and wind direction. Then we can also compare to the information on change in factory utilization and power traffic as a socio-economical data. GEO may be help to share such in-situ meteorological and socio-economic data sets and provide any opportunities to validate the results from the satellite. This is another example of CO2 change detection. JAXA has greenhouse gas observing satellite second generation we call the GOSAT-2 to observe atmospheric CO2, carbon monoxide, and methane. GOSAT and GOSAT-2 are global GHG monitoring satellites in support of the Paris Agreement with regard to supporting the national GHG inventory. Under the COVID-19 situation, it is typically expected that anthropogenic CO2 emission would be reduced in line with the human activity lockdown. The CO2 will be observed a certain unit of column concentration of atmosphere. Usually, atmospheric wind may be affected to deviate the value of CO2. Therefore, we divided the atmospheric column into lower and upper troposphere. Then difference between lower troposphere and upper troposphere was derived so that more accurate anthropogenic emissions could be identified. In left-hand side, there are two charts up and down. Upper chart is February 2019, and down chart is February 2020. You can see that CO2 reduction has been identified in China and European region as red circle indicated. This timing is mostly coincident with when China and European were in the middle of spreading the virus and lockdown situation. In right-hand side, upper chart is March 19, March 2019, and down chart is March 2020. You can see that CO2 reduction has been identified in US and Middle East region. The timing is mostly coincident with virus has been spreading and in lockdown around the US or maybe in Middle East areas. The results are, of course, very much interested in seeing more detail, but we, as space agency people, are not in the position to mention whether it is because of the COVID-19. We think it is necessary to engage with experts on socioeconomic in order to further analyzing the societal impact and assessment. I think this would be a good opportunity in GEO for coordinating a new engagement in order to be effective narrative, the Earth observation effect to society between EO community and socioeconomic community. JAXA will certainly continue to monitor these parameters regularly, day by day, towards long term, as long as the satellite operating. And also, we will share the data openly and freely via our website. We believe the strengths of Earth observation satellite datasets are for providing capability on global basis and regular monitoring. And also, Earth observation satellite datasets are also able to come back in the past to provide the information on what has happened in periodically. Thoughts in more international level, during the lockdown period in April and May, European Space Agency, NASA, and JAXA have discussed and quickly initiated collaborative activities that target COVID-19 impacts and recovery efforts by utilizing multiple Earth observation satellite datasets. The COVID-19 slowdown and recovery provide an unprecedented opportunity for assessing, refining, and improving tools for tracking and quantifying the impact of these activities on the environment, such as air pollution, greenhouse gas emissions, water quality, agriculture, and economic impact on industry, port, and airport construction. There have been huge amount of efforts devoted by staffs in 3 space agencies in this short time period. The result will be under preparation and will be available to public around end of June. Also, some of you already know that we have organized an exciting event on May 30 to 31st. The Space Apps COVID-19 Challenge was global virtual hackathon held, which included about more than 15,000 registered participants from 150 countries that was organized. And 5 partner space agencies such as NASA, ESA, JAXA, CSA as a Canadian space agency, and CNES, French space agency, host 12 challenges with relevant space agency Earth observation data sets. The challenges covered 4 thematic areas. First one is virus and its spread. The second one is local response, change, and solutions. Third one is change in the Earth system response. Fourth one is economic opportunity impacts and recovery during the and following COVID-19. And the result would be the participants used a custom online platform to form more than 2,000 teams and used 24 chat channels in 6 languages to engage with the teammates and subject matter experts. And participants submitted more than 1,400 projects that will be evaluated by the partner agencies. And judges will be from June and August in this year. Finally, global winners will be announced in early August. Winners invited to a lunch at the NASA site, travel permitting, and opportunity to incorporate projects into the Eurodata tubes. So this is a very exciting opportunity of space agencies to work with experts in order to make a really contribution to the COVID-19. So this is all my presentation. Again, I would like to stress the importance of the potentiality that Earth observation satellites could provide support for any level of decision-making process. Thank you very much for listening.
Thank you, Samu, for that outstanding presentation. And now, as Astrid mentioned, we're going to continue our world tour back to the Americas region with Jorge Cabrera Hidalgo, who has been a significant leader in the region of Central America and currently is the Office Advisor to the General Secretariat of the Central American Integration System. And he's going to be talking about the geospatial information systems in Central America and the regional response to COVID-19. Welcome, Jorge, and as we pull up your presentation.
Thank you very much, Elena. Good morning. Good morning, everyone. My name is Jorge Cabrera. I am advisor of the General Secretary of the Central American System of Integration, SICA, and I'm going to introduce this presentation with the three main challenges that our region are confronting in those days. One, dealing directly with the pandemic of COVID-19. The second one has to deal with the economical crisis, dealing with the unemployed facts regarding the measures coming from the sanitary measures that we have of isolation and all that aspects, and the problem of employee who affects the most of the people in the region, mostly those vulnerable groups who includes indigenous people, Afro-descendants, and people who lives in poverty situation. And the third one, who we call complex scenarios, include over these 2 points that I already mentioned, is the starting of the hurricane season in the region, who already present very serious economical and human impacts with hurricane and the tropical depressions Emma. First of all, let me tell you that the 12th of March, the presidents of the Central American countries, we have 8 countries working together, we celebrate a meeting for the presidents that we call Central America Unit against the COVID-19. In that meeting, the presidents approved the regional contingency plan to affront with sanitary measures the pandemic of the COVID, and also includes 3 main axes of work. One, dealing with health and disaster prevention, who was working within the authorities of health and the authorities of risk management and social civil protection. The second axis is commerce and finance. In that area, we received the support of the Central American Bank of Economical Integration, CABE, with $1,900 million to support the regional capabilities and the countries to attend the financial crisis and to attend also the problem of the employees in the region. And the third axis has to deal with security, justice, and migration. That includes also another 2 aspects very important for the region, who are food security, and to provide to the region to strengthen the capabilities of the science networks within the universities and scientists of the region. Also, this plan includes a regional strategy of communication, all the things who has to deal with the coordination of the cooperation and the digital platform of the Central American System of Integration. Now let me introduce a short video from the Center of Disaster Prevention for the Central American region, CEPREDENAC, when we want to present you the regional platform that we are building with CEPREDENAC and the Regional Committee of Hydraulic Resources.
El Centro de Coordinación para la Prevención de los Desastres en América Central y República Dominicana pone a disposición la Sala Regional de Información y Coordinación para la Prevención de los Desastres y el Manejo de la Información. Esta plataforma virtual permitirá fortalecer las capacidades de respuesta y resiliencia de la población más vulnerable de Centroamérica y República Dominicana. Esta sala provee las herramientas tecnológicas de información para un acertado proceso de planificación de acciones para el desarrollo de estrategias regionales y nacionales en la reducción del riesgo de desastres, basados en el conocimiento e integración de datos y modelaciones para la evaluación de impactos que nos permita entender el riesgo de desastre. Por medio de la Plataforma de Información y Coordinación para la Emergencia Zika COVID-19, los gobiernos, instituciones y actores vinculados en la respuesta de la emergencia pueden acceder a los datos oficiales de la región, tales como casos confirmados por país de afectados, fallecidos y recuperados. También permite identificar población expuesta por país y las capacidades que los países han puesto a disposición como estrategia de atención, identificando hospitales priorizados y centros de aislamiento. Por otra parte, genera datos en tiempo real que apoya la toma de decisiones para brindar una eficaz, ágil y oportuna respuesta a las emergencias y desastres en la región centroamericana y República Dominicana. Esta plataforma nos permitirá realizar una planificación más acertada en la respuesta a esta emergencia. Centroamérica y República Dominicana estamos unidos para contener el coronavirus. Juntos saldremos adelante.
To finish this presentation, let me you know that some of the activities that we are developing with the cooperation with NASA and GEO programs. First of all, the 20th of March of 2019, Central American signed with NASA a joint declaration in Costa Rica. For this time, just 4 of the 8 countries was formal members of GEO. At this time, 1 year later, all the 8 Central American countries are members of GEO. That is one of the advances that we receive. Also, the support of the different programs of GEO, like GEO Gloves, GEO Dharma, GEO Glam, to support our institutions translating information, geospatial information to our platforms of information for the political decision making. Also, for this moment, we have finished 9 projects with the developed program of NASA in different areas like protected areas, in border areas, water quality in coastal marine zones, air quality and landslides, and index of dry in Honduras and Nicaragua, and another one from protection of the ecosystems in the country of Panama. Also, we receive instructions for the uses of the instruments of Google Earth Engine in the other products. We have developed from this time more than 70 video conferences with a total participation around 1,500 participants coming from the public sector at the regional, at the national level, and also the participation of the universities of the 8 countries of Central America. And the 10th of June, we're going to have the launch of our platform with Copernicus and Galileo in cooperation with the European Union. We want to thank again all the support of the GEO programs for our region to strengthen our capabilities to have the decision-making of the politicians under a scientific basis, in this case in geospatial information. Thank you very much.
Thank you, Jorge. Thank you, Jorge, for that great presentation and great visualizations. We're going to move ahead in our continuing world tour. Before we move ahead, I do want to remind everybody to please submit your questions through Slido with code GEO. It's code GEO to submit your questions for our presenters through Slido. I would now like to introduce Vincent Henri Pope, Head of the Copernicus Atmosphere Monitoring Service and Deputy Director of the Copernicus Department at ECMWF, and Carlo Buontempo, Director of Copernicus Climate Change Service. As you well know, Copernicus is a cornerstone of the global Earth-observing satellite constellation. They will both present today on Copernicus activities in support of investigating COVID-19, air quality, and climate connections.
Hi, I'm Vincent Henri from ECMWF, and I'm joined with my colleague Carlo Buontempo to speak about the activities that we've done in Europe in the context of the Copernicus program, investigating the links between COVID-19, air quality, and climate. We've been looking at a number of questions, investigating the links between air pollution and COVID. I won't have time today to speak about the investigation of long-term and short-term exposure to the development of the disease, or whether particulate matter can play a role as a vector for the virus. I will focus my talk on what we've seen regarding changes in emissions and concentrations for key pollutants during lockdown measures, which has also consequences in terms of reducing morbidity and mortality due to air pollution. So you've probably all seen such images of showing before and after measures of lockdown have been taken. These images have been largely taken from Sentinel-5 precursor, tropomi, showing NO2, which is a very convenient pollutant, having a short lifetime. And what you can see on this plot is a comparison of a month's worth of data, comparing 2019 and 2020 with a quite substantial decrease in the amount of NO2, which is a pollutant which is mostly emitted by road transport. There was another great thing for Earth observation, I think, which is that we could actually show that this information provided by Sentinel-5 precursor is actually, which is vertically integrated columns of NO2, is actually matching very well what we see from the ground in the form of the analysis of surface observations. And what you can see here is a time series comparison of the total column measured by the satellite in red and the surface analysis in black from our CAMS system from the beginning of February until the end of April. And what you can see, the day-to-day variations are very much in sync and highly correlated, which really means that satellite observations can be used in this analysis. And I think this is fairly new in our domain to see that the skill of this instrument is now so good that we can have such comparisons. There have been a lot of things in the media, in press, looking at these effects, but we have to be very cautious that, of course, as you all know, the concentration of pollutant at the surface do not only change with emissions, but they change also with weather. And what is plotted here is the same time series except for Madrid, and below you have the time series for the height of the planetary boundary layer and the wind speed. And what you can see is the concentrations of NO2 at the surface and the two weather parameters that we have extracted are very well anti-correlated. You can see that on a synoptic scale, when the planetary boundary layer is high or the wind speed is high, concentrations are low because mixing is very substantial. and vice versa. What you can see also is that with going towards summer, the PBL height is going up, so this is a green curve, and consequently the concentrations at the surface of NO2 are going down. So there is a big scope for confusion between the signature of COVID measures and the effect simply of weather at synoptic or seasonal timescales. So in order to study these questions, we've opened a mini site with the web address here. And what we do is that we provide a number of complementary ways to look at these changes. We offer the possibility to look at climatological anomalies, so comparing 2020 with a few previous years, as you can see on the time series which is there for Turin. We also provide some information in the form of comparing the analysis with the control run, so in technical terms, data assimilation increments. So that is telling us what observations tell us that is not in business as usual models. And finally, we've been doing also some scenario runs. So with the help of the Barcelona Supercomputing Center, in that case, we have estimated changes in emissions. Here you have an example with a bar chart regarding road transport. You can see that looking at European countries, reduction have varied between something like minus 20% only to about 80%. So it's very important to do a detailed assessment based on mobility as provided, for instance, by Google or by TomTom. And then we run models to compute the differences. And finally, we've been working very closely with the WMO Global Atmosphere Watch community. And the great news is that there was over 100 teams that responded to a questionnaire, meaning that the community is extremely active and looking in all these questions. Let me give the floor now to my colleague, Carlo.
Hello everyone. I'm Carlo Bontempo and I'm the director of the Copernicus Climate Change Service at ECNWF. And I will be talking about one specific question related to COVID today, which is the link between environmental condition and especially temperature and humidity and the outbreak of COVID-19. So specific environmental conditions are more or less conducive to the outbreak. So this is one of the things we have done as part of the Copernicus Climate Change Service, and has been to put together an application that links to the data we have in the catalog. So the centerpiece of the architecture of the Copernicus Climate Change Service is the so-called Climate Data Store that provide standardized access to reanalysis data as well as observation from satellite, projection from climate model and seasonal predictions. In this case, what you see on this map is a distribution of temperature in the last few months. So this is for the month of May. And what's on the plot at the moment is the temperature field. And you see region with different color, and we use a color scale that is linked to early studies suggesting that specific interval in temperature and humidity are more conducive to the outbreak of coronaviruses. So there is quite a body of literature linking specific environmental condition to transmission of coronaviruses. For this specific coronavirus, which is quite new, we don't know exactly how susceptible to this temperature and humidity fluctuation the transmission will be. And that's why we put together this application. So the red dots represent the outbreak in terms of number of fatalities per country, while the color represent different environmental conditions. Once you click on a specific dot, you get the time evolution of both the mortality and the temperature and humidity. And what you see on the plot on the right is exactly that evolution. The white band, which for temperature is between 5 and 11 degrees Celsius, and for humidity in green and yellow is between 3 and 6 gram per kilogram. The white bands are the regions where, according to some preliminary studies, the transmission may be favored. As you can see in the map, though, there are significant outbreaks outside of this region, meaning that at the best of our knowledge at the moment, the environmental condition may slow down the intensity, but doesn't actually manage to stop it altogether. If you're interested in the app, you can play with it yourself by following the URL you see on the right. Next slide, please. And as any application on the Climate Data Store, the application comes with a description which links to the relevant documentation, so you can see how it was put together and what is the theoretical background for this app. And it comes with the original piece of source code, so you can reproduce every single plot, every single result, and rerun it yourself or alter what we have done if you think you can do better, or you can modify things in a way that is interesting. The important point I want to stress here is that we don't actually know whether environmental conditions will be a major driver or not. We know they are likely to have an impact, and these tools allow health experts, national authorities, and international organizations to monitor more easily the connection between these variables and the outbreak. So it's really a way of operationalizing the climate information to the benefit of a larger group of people. Thank you.
Thank you very much for that fabulous work that you've been doing and for the presentation about it and the resources you've been developing for quite some time. It's amazing to see. So thank you for sharing that. And we are continuing our world tour, as we've said, but I have the opportunity to introduce Esty Garrity from Esri. Sorry about that. Esty is the Chief Medical Officer and Health Solutions Director from Esri, and I've had a great opportunity to work with her for quite some time on various health issues, from cholera early warning to heat health. And Esri's been one of the core partners for GEO for a long time, so we are really thrilled to have her present some of Esri's roles and capacity that they've put together to help the globe manage the COVID-19 pandemic. So without further ado, Esty, welcome and thank you very much.
Thanks, Julie. I'm glad to be here. Hi, everybody. Hello, it's a pleasure to talk today about the GeoHealth community response to the COVID-19 pandemic. My name is Esty Garrity, and I serve as the Chief Medical Officer and Health Solutions Director at Esri. I've been at Esri over the last 6 years, serving the global health and human services needs of our world. Today, I'd like to share a wealth of resources with you that support pandemic response, while at the same time demonstrate the power of GIS as a collaboration platform. Everything I'll be talking about is part of the Esri COVID-19 GIS Hub, and I'm going to spend the next few minutes showing you what's available there. You might want to take a screenshot of the URL, but don't worry, I will show it again at the end. Now, it's worth noting that we continue to update the materials in this site daily, and to make that easier for you, we post it on a banner at the top so you can check back often. And second, we actually are highlighting the fact that you can request GIS assistance whenever you need it. That assistance is provided by our disaster response program, which has been around for more than 20 years. Now, for COVID-19, we're providing software bundles, solutions, services, and technical support at no cost for those who want to take advantage. To date, that number is over 4,000 organizations. Now, the first thing you'll see when you scroll down in the hub is a set of 4 cards. The first card focuses on health, racial, and economic equity data. When you click on Explore, you actually come to 133 data sets that are relevant to this topic. They're all free and geo-enabled so that you can use them in your analyses right away. The next card points to the world-famous Johns Hopkins University dashboard. This single dashboard has been requested billions of times. At its peak, we were seeing over 3.5 million hits per hour. This one dashboard literally changed the world. It inspired countries, states, and cities all over the world to create their own localized dashboards. It informed the world about what's going on. It built an expectation around the world for authoritative and near real-time data, and it promoted the idea of data sharing since they made their underlying data set available to everyone. I'm excited to show you the next card, which is really a system of systems approach to cataloging the world's GIS applications for COVID-19. This is what it looks like. You can see right away that there are 288 contributed applications here. You can select by country in the alphabetical list, and here we see that Argentina has 9 GIS applications contributed, or you can select a country on the map. So then you can see that we've zoomed into Argentina. We can see all 9 of their applications across the top, and when you click on one, you're going to get a preview of that application that you can start to interact with. Or you can copy the URL or simply open the application in full screen. For anyone that would like to contribute their ArcGIS application to this catalog, it's easy to do. We have a short form for you to complete. Just contact me and I'll send it your way. Now we have a similar system of systems catalog for the US applications, which currently holds 377 shared resources. The next thing you'll encounter as you explore the Esri COVID-19 GIS Hub is a compendium of death forecasts using 11 different expert models collected by the US CDC. You'll also see a US county trends map that looks at the last 14 days, updated daily, to determine where in the pandemic phases each county lies. That goes from emergent to spreading to controlled. I've added a link to a blog that explains the methodology, and it links to the same kind of trends map for every impacted country. As you scroll down the hub site, you'll see that it's organized across 3 broad areas: getting started, getting data, and getting updates. In the Getting Started section, you'll see the 5 steps that we've been recommending responders use to understand COVID-19 and its impact. They are mapping the cases, mapping the spread, looking for vulnerable populations, understanding your capacity and your ability to surge, and communicating with maps. I'm including a link to my blog explaining these steps in detail, as well as my latest blog with the 5 spatial approaches to safely reopening. As a Chief Medical Officer, these steps and approaches really reflect the way that I think about GIS and its utility in a pandemic. In the Get Data section, you'll find lots of open data. On the front page, we share some featured data sets like weather information, sentiment analysis, and social distancing metrics. The social distancing data are actually very interesting and useful. Whether you're looking at community behaviors like you can with the Unicast county-level social distancing grades, or maybe you want more granular block group analysis of the percentage of people staying home versus pre-COVID-19 days. SafeGraph also provides a points of interest data set so that we can see the places where people are congregating more often, like grocery stores, or less, like entertainment venues. Keeping an eye on these data will be critical as leaders start to reopen communities and try to balance the economic health with the public health. The next section in the hub is the featured story maps, because sometimes we just need more than data and apps. We need a narrative to put things into perspective. The section for getting updates provides both professional and public level information from some of our most authoritative agencies, the World Health Organization, the US CDC, and the European Center for Disease Control and Prevention. I'll also note that Esri is providing free COVID-19 response packages to Ministries of Health and Global Outbreak Alert and Response Network partners so that they all have the needed tools for reporting, analysis of cases and deaths, and all of their response activities. And now I'd like to bring your attention in the upper right to the resources page. Here's where you're going to get the tools you'll need, starting with ArcGIS Pro COVID-19 Modeling Toolbox. This has spatial versions of the University of Pennsylvania's CHIME model and the CDC's COVID-19 surge model. These are both forecasting models to understand the potential impact of cases on our healthcare systems. Here's an example of the CHIME model and 2 different social distancing scenarios in the state of Florida. Now, with more strict social distancing, you can see the yellow curve is flattened with regard to ventilator needs. However, with lax social distancing, the orange curve shows a likelihood of exceeding current ventilator capacity. And with the maps, we can see which hospitals in the state will be most impacted. This slide is showing how multiple different models can be compared using Arcgis Insights, which is included in the disaster response packages. Our solutions division has been incredibly busy building the kinds of solutions that people need to be able to respond. Now, the idea is that these are super easy to deploy, easy to use templates, freeing up development and configuration time, which we know nobody has during a crisis. The arrow is showing that there are even more solutions that can be freely downloaded and used right away. And I know we've all learned a lot during this crisis, and the next area of the hub you'll run into is our documentation of what we've found to be best practices. Again, trying to help people get their jobs done efficiently and effectively. And for technical discussions around COVID-19, we've set up a special GeoNet site to host those conversations. If you've not heard yet of GeoNet, it's like social media for the Esri community to share, connect, collaborate, and be productive. We've also put together a number of how-to resources that will help to build capacity during this pandemic. There are blogs, videos, and very short, to-the-point tutorial-style lessons. We're all working together to keep ourselves, our community, our nation, and our world healthy, and lots of people want to help. For those that have GIS skills and would like to volunteer their services, we're directing them to the EURISA GIS Corps of Volunteers, and they've been doing great work. I'm showing you two examples. The first in the lower left is their Stories of Coronavirus Loss and Recovery, which is a crowdsourced effort that's meant to make the data more meaningful by sharing the stories of real people who've been impacted. The second example is their COVID-19 testing site locator. Now finally, when things calm down a little and we get to the point of debriefings, after-action reports, and examinations of the lessons we've learned, then I think you'll want to look at some more long-term resources to help you get set up with GIS in bluer skies for the next emergency, whether it's a fire, a hurricane, or a public health crisis. So, as promised, here's the URL for the COVID-19 Resource Hub where you can contribute your applications and pull what you want for your local needs. I want to thank you for your attention, and I offer my email address for future contact.
Esty, thank you very much, and thank you for being present while your presentation was being shown. We will have some questions, so we're going to transition here for just a minute. And for all the panelists, thank you for great presentations. And for those of you who are listening, please remember to enter your questions in Slido. The code is GEO. And also, we've gotten a few questions that have been asking, yes, the videos will be available on the GEO website, so you can access them after that. So we're going to transition now just for a minute on to some of the resources available for the community. But I wanted to remind you all that our community of practice sort of spontaneously stood up the COVID discussion. We were very well positioned to do that. And so the presentations you've heard are highlights from across the community of practice, things that we've actually heard, people who've presented to us in our community of practice. And the resources I'm about to share with you are also those that the community has shared with us. They are available and accessible on our GEO Health website. You'll see in just a minute. But I just wanted to make sure that if you don't see your work here, please let us know. We're happy to, link to some of the resources that are available. And just make sure that you tap into our community of practice, because we would like to hear from you, and we are just really thrilled that we were able to serve the community and be a place where people can come and just have a discussion about who is doing what. So I'm going to spend just a couple of minutes going over resources for you. I'm going to share my screen now and make sure that works all right. Okay, so as I mentioned, these are just some resources, significant resources, but that were shared with us during our Community of Practice weekly teleconference calls. So as you heard from John Haynes earlier, I co-chair the group with him, and Helena helps run us, and we are really designed to be a network of organizations working at the interface of Earth Obs and health. And you can see our work groups on the left side there. So if you're interested, our GEO Health Community of Practice website is down below. Please check it out. We, in the response for COVID, had set up a series of weekly phone calls just to discuss what the state of play is on Earth Obs and COVID. We have been doing deeper dives, and you'll see some of the topic areas listed if you go to the site, including a deep dive on seasonality and on environmental drivers and on One Health and water resources. So please join us if there's a particular topic that you would like to see addressed as well. Let us know that. We also cover funding opportunities and the challenges that you heard mentioned, the NASA Apps Challenge, some upcoming challenges as well. So check that out.
Julie, this is John.
Yes?
I don't think we're seeing the slides.
Oh, okay. Let's try that again. Let me go forward. I can see why it's not exactly loading.
Julie, I can share your presentation if you want.
Yes, okay, that would be great, Rick. Thank you. All right, so we'll start over a little bit. All right, Rick, can you go to slide 2, please? That was where I was explaining the Community of Practice, and you'll see the website there, so I'll just regroup a little bit. So the Community of Practice, you see our work groups on the left. If you're interested, please check us out. Go ahead, next slide, please. And this is where I was mentioning we do have weekly teleconferences. They are on Tuesdays, 8:30 a.m. to 10 Eastern, hopefully, again, to try and accommodate some global participation. I mentioned the funding opportunities that are listed, so current funding opportunities are you can check them out there, as well as some of the challenges. We've already heard about the NASA Apps Challenge, and some other ones are also listed on our page. Next one, please. So you've heard a little bit about some of the Copernicus data and tools available. Please check this out here. They've got the Climate Data Store. NOAA, my own home institution, has created a page that is specifically targeted to help serve the COVID research and modeling community. Next slide, please. Those are both really, have opportunities and access for researchers to ask questions of us as well, to work with us on making sure that you've got the right data and know how to use it. Similarly, the NASA COVID Pathfinder, again, taking you through how to use and how to find the NASA data. And also you'll see on the right-hand side a nitrogen tracking page as well, COVID NO2 page from NASA. Next slide, please. From Copernicus, you also see a new dashboard. I love the name, Rapid Action Coronavirus Dashboard, RACE dashboard, and also some of the EU space program information, especially you can see some of the nighttime lights and that sort of work going on there. So please check both of those out, especially the dashboard's one of the newest contributions to the set of resources. Next slide, please. Globally, there is a group called the Global Heat Health Information Network. It is run out of the joint WMO-WHO Office for Climate and Health in Geneva. They have done a series of information packages for heat and COVID. There's a checklist, some information sheets. There are actually a series of heat and health master classes that just started last week. The next one is this week as well. So they are not all specifically targeted for COVID, but they are about heat and health. and then the dialogues that are going to be focused on urban and occupational health, that's July 28th and 29th. And then you already heard before from Francois about an upcoming workshop, Climate, Meteorological, and Environmental Factors in the COVID-19 Pandemic. That's going to be August 4th through 6th. It's a virtual symposium. The website should be stood up soon, so please keep your eyes on the GEO Health Community of Practice website for updates on that. And think about, this is the time where we can really do a very deep dive on the topics that we're discussing here. So our presentations just sort of hit the high notes of what's going on around the globe, what are the big topic areas, but this conference will be a chance to really get down into the nitty-gritty about what are the important parameters, what should we be predicting, what are the drivers, what's the latest science. So it's a very sort of breaking issue kind of conference. Next slide, please. I believe that's about it. Training opportunities. Yes. So NASA has some standing training opportunities about access to their data and tools. And then I already mentioned the space app. So let's keep going. Just in the interest of time, I want to leave time for questions. All right. So just a reminder, if you have questions about the resources or anything, please go to the Community of Practice website, join there. That will make sure that you get the latest updates. Elaine is great about sending things out. Join our calls on Tuesday. And without further ado, I think right now I want to just say again, thank you to all of our panelists, and I want to remind you to send your questions into Slido. And I think that I will turn it over to Helena and Astrid, who are going to manage our Slido questions session.
Super. Thank you. Thank you, Julie. Thanks, everyone. First answer is thanks, everyone, for your presentations, and also thanks to the audience for the questions on Slido. We will not have time because we're already running late to answer everything, but don't worry, we will do that in writing. But now we start the first question. I would like to address that to Vincent Henry. Is a question from Lindo Mai, which kind and by how air quality Earth observation data set can be used for the investigation of COVID-19? So, floor is yours, Vincent Henry.
Thank you, Astrid, and thank you for the question. It's a question that would take a very long time to answer in detail, but already in this session you've seen a number of satellite Earth observation data set that can be used. We've seen aerosol optical depth, we've seen NO2, there was also a CO2 mentioned, so there are a number of satellite data streams that are available, and through modeling, the possibility to convert generally vertically integrated information to surface concentration and surface value that relate more directly to the health aspects. In the presentation that Julie has just shown, there are a number of portals that are a very good starting point to explore the data available, and also a product which is maybe very interesting for users which are outside of the traditional Earth observation business. These are analyses, and the analyses are using models to put together observations from satellite or from the ground, because we should never forget that in many places of the world there are very good surface-based observations. And through this process of data assimilation, we can have analyses which are gridded Hawley fields, which then are very easy to confront with health data, for instance. And I'm just finishing by mentioning a study that we are conducting in France over a large cohort, and the analysis that we provide help assess what have been the long-term and the short-term exposure of people in the cohort. In that case, it's about 2,000 elderly people, and to investigate to what extent the exposure to certain air pollutant, NO2, particulate matter, but also to weather parameter, has had an effect on the outcome of the disease. So please maybe start from the presentation of Julie or from the website itself. There are lots of very good leads to get going with these studies.
Okay, thank you very much for this very concise answer to, could be a lot deeper dive, I think, for the future. So let's now move on to seasonality. And for seasonality, I think the expert here is Francois. And by doing that, I just want to give first kudos from Amos from Ghana, saying really nice words from South Africa on seasonality impacts on COVID-19. Would the team be willing to work with West Africa, Ghana, to check validity of model? And the other question, same thing, but it's more on Brazil. It's from Monica Kuffer. How can influence of seasonality be related to the growing number of COVID-19 cases in Brazil? And if you could do the answer in 2 minutes, we would be grateful. Thank you.
Thank you very much for these questions. It's very, very good to hear from a colleague in Ghana. Of course, we'll be very, very keen to collaborate and to also include climatic and case data from Ghana in our Africa-based assessments of COVID-19 and seasonality. So please let us be in contact in this respect afterwards. And then I think, as Ben also mentioned quite clearly in his talk, there are currently, as we all know, cases being reported from very, very different climates from across the world, including many tropical countries that are reporting cases. It is clear that high humidity and high temperatures are not providing complete protection at all in terms of an infection breaking out in countries with such climates. So there are so many other factors, such as socioeconomic factors, the ability to implement social distancing, that also play a role. So I don't think the fact that we have outbreaks in tropical countries are making the case either for seasonality or against it. It just demonstrates very clearly that we cannot rely on high humidity and temperatures to save us from outbreaks in such countries.
Now, next question is for Osamu from Lindomai. Is for aerosol optical thickness, we can make sure that the aerosol is caused by the lockdown and not by natural sources, especially since AOT contains both elements. So, Osamu, can you say a little bit about that? Would be wonderful. Thank you.
Thank you so much for this question, and I appreciate it. Can you hear me okay? Okay, so I think, yeah, this is true. I think we are all not sure from our space agent side whether that AOT is from the COVID-19 lockdown or natural effects. So that I would like to stress about integration or maybe assimilation between the satellite and also the in situ networks. And particularly ECMWF, Bansan mentioned about the modeling with the in situ bottom-up with modeling cases to try to compare analysis between the satellite and in situ is quite important. Whether the source of this optical thickness decreasing will be caused by the lockdown or natural basis. So that I think GEO is a quite thorough that such kind of analysis and also the integration activity between the satellite data and models is so that maybe it might be worthwhile to making some sort of initiative to try to making a progress to try to collect more data sources and then integration study, and that makes happen more international consequences to come forward. Thank you so much.
I think we have so many questions, but I don't think we have enough time for answering all these questions. So as we said before, they will be answered on our website. And I now would like to give the floor back to John for the closing remarks. Thank you.
Thank you, Astrid. And again, thanks to all of our presenters today, and thanks to all of you in the community for giving your time this morning, afternoon, or evening to join us in this discussion. But this is just the beginning of the discussion. This discussion is going to continue as long as we face this global challenge. And so, again, as Julie, Astrid, and Helena said, please join our GeoHealth community of practice. Visit our website at geohealthcop.org, where you can find a lot of information and presentations, even more presentations than what we're discussing today, because all of our presentations for each of our weekly telecons and the notes from those telecons are archived on our website. So please join the community of practice. We would love to see you at our next telecon, which again will be on June 23rd at 8:30 a.m. Eastern Daylight Time. That's GMT -4. And the discussion will continue. So on behalf of all of our panelists, on behalf of my co-facilitators, Julie Turton, Astrid Christina Koch, Helena Chapman, and on behalf of the GeoHealth community of practice, thank you for joining us, and stay safe, stay healthy, and stay socially distanced. Thank you.